Today we'll be talking about cylindrical shells. Cylindrical shells, or just shells, is a process of integration of 3D solids formed when a plane is rotated about an axis. The most common way of seeing shells is when a plane is rotated about the y-axis and we integrate with respect to x. This is not the only way to see shells, though. They can be integrated with respect to y and around any axis. The first thing to do is picture it. It is find the integral of the size of the cylinders formed when rotating a plane. A good example is like a roll of papers. When we can measure every little sheet in a roll, we can determine the volume of the roll. The area of a cylindrical shell is 2 pi rh. Our first example we're going to use is an area bound by three functions, 1, 2, and 3. The third one is just a vertical line. And the height is the first thing we need to identify, and that's going to be the difference between our first and second functions. Because every shell's wall is going to have a vertical line along that, just like this. Next thing we need is the radius. The radius of the shells is just going to be x, because the distance from the center is the radius, and that's x. Now we're going to write this in integral form, 2 pi of the integral of rh dx, and r expands to x, and h expands to f1 minus f2. Now the limits are going to be from 0 to f3, because f3 is the final point in the shell. And that is the general form. Example 1. What is the volume of an object created by rotating the plane bounded by x to the third, x equals 2, and the x-axis around the y-axis? Let's start with a sketch to help you understand what you're trying to find. So that's x to the third, that's x equals 2, and that's y equals 0. The area in between rotated around that axis there. So now let's write the equation. Shell is 2 pi rh. R equals x, again in this case. H is going to be x to the third minus 0. 0 because the third equation bounding it is y equals 0. Now let's write it in integral form. 2 pi of the integral of x times x to the third minus 0. That's just rh again. Our limits are going to be 0 to 2 because our side boundary is x equals 2. We're going to go ahead and combine those x times x and x to the third to x to the fourth. Evaluate our integral. Alright, moving on to the next page, it's the same thing. 2 pi times 1/5 times 2 to the 5th minus 1/5 times 0 to the 5th. 2 pi times 2 to the 5th over 5 minus 0. And we're just going to leave it like that. You try. So what is the volume of the solid created by the plane bound by 3x squared plus x equals 3, and the x-axis revolved around the y-axis? Let's pause the video real quick. Let's draw a picture first. It doesn't have to be exact. Let's just do our best. Let's rotate around that axis. Now let's write out the equation. 2 pi rh. We're going to sub in right now. R is just x. H is 4x squared plus x. Now let's put it into integral form to help us calculate. From 0 to 3, our side boundary is x equals 3. That's where the 3 comes from. And don't forget the dx. Now we're going to go ahead and solve this. It's 2 pi from 0 to 3 of 4x to the third plus x squared dx. 2 pi from 0 to 3, x to the fourth plus 1/3 x to the third. Now we're going to go ahead and sub in the numbers. We don't have to worry about 0 because it's just going to come out to be 0. It's 2 pi times 3 to the fourth plus 3 squared, 2 pi times 90, and that comes out to be 180 pi. Alright guys, thanks for watching. Go ahead and click the link to go back to our website and learn more about cylindrical shell method.